Assalamualaikum warahmatullahi wabarakatuh. My name is Deni Shakib bin Muhammad Azidin. My ID 2022459254.
My name is Asfar Suhaib bin Azidin. My ID number is 2022-839782.
My name is Azmi Ashraf bin Aznel. My student number is 2022-621338. So we are going to present about fan mode controller with the IP switch. For introduction, we are required to design and implement a fan mode controller using the HCS 12 Dragon Board microprocessor. So for the system features that we are required to do is to control fan mode through a DIP switch input, and LEDs indicate the active fan mode. A buzzer provides sound feedback for mode changes and deliver a real-time responsive and efficient control system for fan mode management in embedded system. So for the purpose of the fan mode controller, the first is efficient fan operation that enable precise control of fan mode to optimize energy usage and enhance performance. Second, user-friendly interaction to provide an intuitive interface to DIP switch, LEDs, and a buzzer for easy selection and monitoring of fan modes. The last is demonstration of embedded system concept that serve as a practical application of microprocessor-based control, showcasing skills like port configuration, interfacing, and a real-time signal processing. Next is significance of the system. The significance of the system is to demonstrate the integration of hardware and software for real-time control, showcasing microprocessor functionality in managing complex tasks, and then provide a simple and user-friendly setup with the IP switch, LEDs, and a buzzer to easily select and confirm fan modes. The last one is to provide a structured approach to a fan mode management, enabling optimal energy use and adaptability for various applications in embedded system.
For this project, we are using one input, which is DIP switch, and two output, which is LED and buzzer. For figure 1, schematic diagram of DIP switch. For figure 2, schematic diagram of LED. And for figure 3, schematic diagram of the buzzer. And of course, we are using HCS 12 Dragon Board. And these are the schematic diagram of HCS 12 Dragon Board. These are the flowchart of the fan mode controller. The system begins with configure port, and the system will read the IP switch, which is PTH, and send output data to LED, which is PTB. If the switch state is A, which is turn on the IP switch in sequence, for example 1, 2, 3, and 4, the buzzer will turn on and the system will end. But if the switch state is B, which is turn on the IP switch not in sequence, as for example 1, 2, 4 or 1, 3, 4, the buzzer will turn off and the system will end.
Now I will present the coding with comments, starting with include the header file for the HCS 12 microcontroller until BCLR PTJ02. This section set up the microcontroller by configuring ports for input or output as required. For example, set port P as output, set only LED 1 to 4 as output. Next, set only the IP switch 1 to 4 as input, set port J for buzzer, set port J bit 0 as output, set port R for signal toggling, and clear port J to initialize buzzer off. Next, load 0 into accumulator A until LBEQ condition 1. This section handles the main program logic, starting with loading and initial value. Data from the IP switch is processed and displayed on LEDs. Conditions are evaluated to determine program flow. Next, the button condition, which is CMPB. CMPB for declare condition for buttons 2 and 4. If equal, jump to condition 1. Next, condition for button 3. If equal, jump to condition 1. And so on. This part evaluates the states of buttons and direct the program flow based on conditions. Next, state change handling, starting with move B PTH until BEQ no change. This section compares the current state with the previous state to detect any changes in input. If a change is detected, further action are taken, otherwise the program skip unnecessary steps. Next, for buzzer control, starting with B set PTJ 01 until B CLR PTJ 01. This section, the buzzer is toggled on and off with a delay in between to indicate a valid input or state change. Next, for delay subroutine, starting with delay, and last is RTS, which is written to main program. A simple delay subroutine that loops a specific number of times to create a time delay. For the discussion of this project, the project effectively demonstrates a microprocessor-based solution for controlling fan modes using the IP switch, LEDs, and a buzzer. The DIP switch were effectively used as the input mechanism for selecting fan modes. The LEDs accurately display the selected mode in real time. The system demonstrates reliable detection of state change in the IP switch, triggering the buzzer to provide audible feedback for mode selection. At last conclusion, the project effectively implemented real-time monitoring and mode selection. The integration of a buzzer for mode change notification enhanced user interaction, showcasing the system usability. This project successfully demonstrates the integration of hardware and software components to create an effective and practical microprocessor-based fan mode controller system. That's all. Thank you.